So the last time we were together, we looked at how we could find limits from tables. And when we were looking at the tables, we saw that it would have to approach the same value from both the left side and the right side. Okay, they would get closer and closer. So today we're going to learn a little bit more about one-sided limits. So one-sided limits are functions that approach different numbers from different sides, so from the left and the right. And we're going to observe this with the piecewise function below. Okay, so I asked you guys to graph this. Okay, so you graphed 0 if t was less than 0. So remember, if it's less than, you have an open circle, and then it's going to be going to the left at y equals 0. Okay, and then for this one, it's equal to 1 if t is greater than or equal to 0. So remember, the t in this case is your input. Okay, so this is your t, this is your h of t. Okay, so the first thing we're going to look at is what happens as t approaches 0 from the left. Okay, so if we go to the left side of the graph, it's getting closer and closer to what number on the y? It's getting closer and closer to 0. That is correct. Now on the right side, if we look at it approaches 0 from the right, which would be, we followed this line, it gets closer and closer to which value? 1. This one is going to be 1 because you're getting closer and closer to this value. Okay, now if that happened on a two-sided limit, that's when we would say that the limit does not exist, right? Because it's going to two different places. So if one side's going to 0 and one side's going to 1, okay, that's when the limit does not exist. So that's what we're going to write for the next one. So since there's no single number the function approaches, we would say the limit as t goes to 0 of h of t does not exist. Okay, that is a two-sided limit. That does not exist because one side is going to 0 and one side is going to 1. What we can do is we can write out a one-sided limit with some different symbols. So what we could say is we could find the limit as t approaches 0 from the left. And the way we show that is with that negative sign right here. So that means approaches from the left. So we're just going to write that in there. Okay, so that's going to be less than 0 if you're approaching from the left. And then it's of our function h of t. So from the left side, we said that that was equal to 0. Okay, and then I think you guys could probably figure out how we're going to write it if we are coming at this from the right side. So this was 0 to the negative. This is going to be 0 to the positive, and of course that means we're approaching from the right. So we have that h of t. So if it approaches from the right, those are numbers that are greater than 0. Hi, good morning. Okay, and then that's going to be equal to 1, which is what we found above there. Okay, so we don't have to do a two-sided limit. If you have the little symbol there, the negative, that means it's from the left. If you have the little symbol with the plus, that means it's from the right. Okay, and you can do a one-sided limit. All right, so then we're going to look at the next example. So I took this from your book. Quality seems to be okay for this. So the graph of a function g of x is shown. We're going to use the graph to state the values, if they exist, of the one-sided limits. The limit, I'm just going to write this out, the limit of x as it approaches, and just make sure you read this as 1 from the left, because sometimes we see those two, even though it's in reverse, and we think -1, right? Okay, so this means 1 from the left side. Okay, and then your g of x, and we're going to find what that's equal to. Okay, and then we're also going to find the limit as x approaches 1 from the right. So this is 1 from the left, 1 from the right. And then after that, we will do the two-sided limit. Okay, so I want you to use this graph. See if you can find where it is approaching. Okay, so this x value is going to be 1. Sometimes it helps to mark that off. Okay, so if you look at your x value of 1, it's right here. So I'm just going to follow that straight up. Okay, so you're going to have to look at this line from the left and from the right. Okay, so if I'm approaching 1 from the left side, I can't follow this line. There's nothing over here. I have to follow this one. So as I'm approaching this from the left side, I'm getting closer and closer to which y value? 5. Now when I'm approaching it from the right side, I'm getting closer and closer to what? 3. Okay, so it says then evaluate the two-sided limit. So if these are not the same, the two-sided limit does not exist. If they are the same, then it does exist, and it's that number. Okay, so you just have to write does not exist. Okay, so if these two numbers are not the same, the limit does not exist. If they are the same, then it will exist. All right, and then let's do part B. So we're going to state these values if they exist. So 7 from the left, 7 from the right, and then the two-sided limit. So I want you to give that a try. Okay, maybe use a pencil just to write down what you think, and then if you need to change it, you can change it. Okay, so give those a try. Okay, so if you are struggling, notice one strategy I did is I just marked this off, right? So I like to just put a dashed line so I can see, okay, what's happening. If this is in a textbook, you can use just like a straight edge. And if it's going from the left side, I'll just cover up this right side so I can see what's happening. Okay, so as it gets closer and closer to the x value 7, what y value does it get closer and closer to? 4. So it's approaching 4. This one is a little different because you can see there is this point here that is intentional. Okay, so it gets closer and closer to 4 as you approach from the left. Okay, it also gets closer and closer to 4 as you approach from the right. Okay, which means the limit does exist, and it is 4. Okay, so I do want to just make a note of this here. So even though, right, if somebody were to ask you what g of 7 is, it's not 4, okay? It's actually 3. So even though g of 7 does not equal 4, g of 7 equals 3. Okay, the graph approaches 4 from both sides. Okay, so you might remember from last week that we said the key thing with limits is it's not what happens when it gets there, it's what does it approach. Okay, so a limit is what happens as you get closer and closer to the value. Okay, and that's because we're going to use it to find indeterminate values. All right, so we're going to do one more example, and then I'll let you do some practice here. Okay, so you are going to graph the piecewise defined function and use your graph to find the values of the limits if they exist. So you have x plus 8 if x is less than 3, and 2x squared if x is greater than or equal to 3. So when you are graphing this yourself, just remember, hey, if it's x plus 8, this is a linear function. The slope is positive, so it's going up from left to right. And we can always do a table, f of x equals x plus 8, to find out what some points are on that graph. Okay, so if it's less than or equal to 3, sometimes I'll just start at 3 and then I'll go down. So 3, 2, 1, 0, just to find some of those points. And then I usually write that there's going to be an open circle here. Okay, so if I plug in 3, 3 plus 8 is 11, 2 plus 8 is 10, 1 plus 8 is 9, 0 plus 8. So that just gives me some points that I can put on my graph. Okay, and then for 2x squared, I know that that's quadratic. So if it's quadratic, it's going to be a parabola. It's positive a, so it's going to open upward. And again, I'm going to use a table to help me with some of these points here. So f of x equals 2x squared. Okay, and then this is greater than or equal to 3, so I do need a closed circle at 3. Okay, and then if I plug in 3, I remember to do my order of operations. So I do 3 squared, which is 9. 9 times 2, 18. 4 squared, 16. 16 times 2, 32. Okay, and then if I did 5, 25 times 2 would be 50. Okay, and with the limits that we are doing, you're not going to have to go all the way up to 5. The highest one we're going to do is 4. So let's at least put the 32 on there. Okay, so I haven't given you all the problems yet, but you won't need to do that one. Okay, so we can go by ones here. Okay, and then to get to 32, I'm going to go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Okay, so I need an open circle at 311. Okay, and then I'm just going to use a straight edge for my line. Okay, so when you're putting these points on, I just make them very small, right? We want to see that open circle. Okay, and then the closed circle at 318. Then at 4, I'm at 32. Keep in mind that this is going to be a curve because it's part of a parabola. Okay, and then once you graph that, you're ready to try A, B, and C. To finish your graph. Okay, so whenever you see that negative, this is 3 from the left. Okay, so not -3. Okay, so if I go to 1, 2, 3 here, I can see that from the left side, I'm getting closer and closer to this open circle that I made here. Okay, so that's going to be 11. Okay, so if I'm approaching 3 from the left side, it's getting closer and closer to 11. And then this is going to be 3 from the right. Okay, so we've already looked at this line. We can see this one isn't here. It's going to be following this. So 3 from the left side is going to be on this line. So we get closer and closer to 18. Okay, which means the two-sided limit, what do we write for that? Right. So anytime these do not match, it does not exist. They do match, it does. All right, and then if it does not have the little negative or plus, that's a two-sided limit. So this means it has to approach the same value from the left or the right. So we have the limit as x goes to 0 of f of x, the limit as x goes to 1 of f of x, the limit as x goes to 4 of f of x. So we're going to do those 3 and then we'll do the last one, okay? All right, so if you look at 0, okay, 0 on your x is right here. So is it approaching the same number from both sides? Yes. What is it approaching from both sides? 8. Okay, so it's 8. And sometimes I will just put I'll just highlight that just to see. Yeah, it's approaching from both sides. Okay, and then the next one is 0. Or sorry, is 1. We just did 0. Okay, so that is here. Okay, and then again, it's approaching the same value from both sides. If you're not sure what that value is, you can always look in your table. So at 1, okay, you're at 9, so you're getting closer and closer to 9 from both sides. That's going to be your two-sided limit. So from both sides, it's going to 9. All right, and then I want you to try the next one. So the limit is x goes to 4.
Okay, so at 4, if I go here, okay, we did do 4 on our table here. So from both sides, from this side, it's getting closer and closer to 32. From this side, it's getting closer and closer to 32. So, yep, this is 32. Okay, and then the last one looks a little bit different. So the last one is not a limit. It is asking you what f of 3 is. Okay, so if it's not a limit, you are just finding the closed circle on the graph when x equals 3. So it can't be the open circle. Okay, because we plugged in 3 here for the open circle. We plugged in 3 here. That's your closed circle. Okay, so it's the closed circle that is your f of 3. If it was a limit, we already said that doesn't exist because they're going to 2 different sides. If they're asking you for f of 3, they're saying what is the output when you plug in 3? And because that follows this part of your piecewise function, your solution is 18. Okay, so for this part of your homework to receive full credit, you just have to draw a sketch of the graph. I'm writing down the homework for this section, but you are turning in day 1 and day 2 together. Okay, and then you'll also be turning in your note sheet. Yes, the day 1 and day 2 are together. We're going to turn those in together. Yep. So this is day 2. Okay, and then so day 1 and day 2 are due together tomorrow in Google Classroom. Okay.